Okay. So there are many options, new options linked to the new technologies or the new times to profile customers or to basically create the perform retail analysis. For example, those based on the courtesy cards or the membership cards. Whenever you go to a shop, for example, I guess you will find something like that in Incredible Connections or this kind of shops. Sometimes they ask you whether you want to open or you are already a member or you want to have a card. Basically, you might get some discounts, but what the shop is offering you is basically yes discounts, but against your data. So they can basically know exactly which people is buying in the shops, when, which kind of articles, and this can be used for them to create this profiling and the retail analysis, and and basically to introduce all this data in the big data and answer questions like what was purchased, when it was purchased, where, and even the name and the address of the person who did the purchases. So those things are basically the ingredients which will create the questions which can be answered by a GIS system. Okay, just to end the unit, we have 2 points, point number 7, point number 8. The point number 7 will cover the Hugh model. Point number 8, just some information about how to do some data management and weight of data, and we'll have also an exercise about that. So the Hugh model is a gravity model. Is by definition is a spatial interaction model that calculates the gravity-based probabilities of consumers at each origin location, patronizing each store in the store data set. Yeah. So basically, it's a model which includes the distance between the potential customers and the stores, and the number of stores and the level of competition of the stores are linked to basically the attractiveness and the distance. There are many elements which basically can define the attractiveness of the distance, like the sales volume, number of products inventory, square footage of sales floor, store parcel size, and many others. Yeah. So this is the basis for the formula. It's a very simple formula where we have the probability of one customer, which is the customer I, to buy in one specific shop, which is the shop J. And then you will have, as if we have a look to the expression here, the attractiveness of the store, which is the reference store, the store involved in the calculations, the distance between the customers and this store, and then the sum of all these factors for all the stores. Yeah. So it's basically, if we have 3 stores, for example, will be the attractiveness of the store 1 divided by the distance of the customer and that store, plus the attractiveness of the store 2 divided by the distance of the customer and the store number 2, plus the attractiveness of the store number 3 divided by the distance between the customer and the store number 3. Then there are 2 factors, alpha and beta, but we are going to assume that those factors are 1, both, so we can remove them from the formula, but they are basically scale factors which will model the level of the importance we want to give either to the attractiveness or to the distance. In some models, it's more important the distance. In some other models, will be more important the attractiveness. So in that case, we'll assume both have the same weight, so it's 1 for both. Here we have a summarized expression for the same formula, but it's basically the same. Both are the same. The applications for this Hugh model are to delineate probability-based markets for store location in the study area, to model the impact of a new competitor in the area, and to forecast areas of high and low sales potential, which can guide new store location placement or refinement, marketing or advertising initiatives. Okay, so also to make estimations of creating hypothetical models. Yeah, so these are the steps. If you use this in ArcGIS, you add your candidates, you add your demand points, and then you will create the best source location for each point. So you can even create a raster product. There is a simple exercise which is included in model, is the attachment number 3. So it's basically a huge model exercise, handmade. So please have a look and try to repeat it. It's an example for the 3 malls here in Windhoek and 2 potential customer locations. Okay, so this whole about the huge model. Now we are going to deal with the last part, which is a very small section of data management. I think there is not much theory behind, because it's also something we covered in class, but I want to include an exercise. Before I go further, I explain maybe the 2-3 methods or 2 or 3 common operations you can do to weight the data or to standardize the data. I'm going to propose you an exercise, one example, one exercise, but without the solution. So you will have to do this exercise before I publish the solution, I upload the solution. So a GIS specialist, okay, let me check the time, just a second. Okay. A GIS specialist has to have knowledge about statistical analysis methods, demography, economics, urban dynamics, environmental studies, and general database design and implementation management, but also IT skills and data management, which is very important. All these science basically include data. They live, they work with data, and the way you manage the data is also very important. There is one technique called normalization, a set of data, which basically is calculated using the following formula: is the specific value divided by the sum of all the values. So basically you put all the values in a data set under the right scale, yeah? And then you can basically also create ranges, for example, from 0 to 1 or 0 to 100, or however you want to enclose your data sets. One example is that one. In the diagram 1, we have 4 suburbs, the A, B, C, and D. And then we have a population and the number of adults. Yeah. We can create a map with the total number of adults, 3, 6, 2, and 10, yeah, as we see in the diagram 2. But if we want to basically standardize and create a percentage according to the totals, we might need to divide this number of adults by the total population to create a value in terms of a range between 0 and 1, or a percentage between 0 and 100. So these are one of the simplest operations you can perform, basically to divide the number of adults by the total population, and then you can standardize the data. But there is no unique method to weight the data. There are different ones, and the one I presented before in the previous slide is one of the simplest cases. But it really comes with the human logic. The human logic to basically perform or conduct the most appropriate operation according to the needs you have for your data. So, as I said, there is an exercise. You will find it in the attachment number 4, and this is the exercise where we are going to practice the different kind of weighting data, or some of them that you might need to learn. Okay, so this is the end for the unit number 4. Thank you very much. Let's work now in the unit number 4. We are going to open different forums. We are going to have a follow-up on the exercise and maybe a final quiz. But I think the material is good enough to work. Yeah, we'll keep on uploading more material. Thank you.